So 3.3 is a pretty important section in its entirety, but this is very much a conceptual objective right here. So we're talking about sampling variability and the effect of increasing sample size. So sampling variability is exactly what it says, that there's going to be variability in your sampling, right? So it's the fact that different random samples of the same size from the same population produce different estimates. You need to memorize this. Different random samples of the same size from the same population produce different estimates. That is going to be a memorized answer that you're going to give for certain problems. So be aware of that. And again, it makes sense. We're not robots, right? In this school, if I ask 20 kids a question and ask the same another 20 kids the same question, I should not expect to get exactly the same result. Hopefully close if I've an idea of how I'm doing it and what I want to measure, right? But again, not exactly the same. So this right here, this dot plot, is talking about your Federalist Papers idea. So I think that you notice that your student sample selected average word length was a little bit higher than the true. So you see how the true average is really 4.9 letters per word. When you chose, and so did I got my eyes gravitated towards the longer words. So you can see that our average word length were above that actual true average. Whereas for the random sample, they were more closely surrounded around the 4.9. But notice that they weren't exactly 4.9 every time. We had a sample here that had an average word length of, let's say, 2.4, just to be fun. And I had two right here that had, word lengths of about, I think that's supposed to be 7.8, right? So again, there's variability even when you do random sampling. It's just going to happen. So again, the idea is that even though the true average is 4.9, not all your samples will have an average of 4.9s, right? They're not all going to be 4.9s. Okay, good. All right, next. So how can sample size help this? Well, you can reduce sampling variability by using a larger sample. What this will do is it'll help you get closer to the true value. You need to remember this. The more people you ask, the better your results. We want large sample size. We want big N values, right? N is that sample size letter. We want the N value to be large. So look at this. This is your average word length. So here, our sample sizes are 5. So we're looking at 5 words like we did in our activity. Over here, we're looking at samples of size 20, so 20 words. Again, here's that true average of 4.9. Notice how spread the data is. This goes from about, we'll say 2.2 all the way to an average of 8, right? That's how spread it is. But now over here, you still have that average of 4.9. That was the true average. And now look at your variability. Look at your spread. It's going from about 3.8 to, we'll say, 6.2. Notice that it is way less spread than this one is. And that is attributed to your increased sample size. If you increase the sample size, your estimates, your sample values will gravitate towards the mean. There will be less spread. Okay. All right. Good. So that's a very impactful slide, I hope you think. Okay, here we go. So example 2, what's the median income in Virginia? The median household income in a random sample of 371 Virginia households is $61,784. Now again, notice they use the word median, right? We talked about median versus mean. So again, there might be some high and low outliers in Virginia, right? So maybe that's why they're focused on the median, to take out those outliers and focus on the middle value of household income. Might be a better measure of center. So question A, do you think that the median income of all Virginia households is equal to $61,784? Explain. Do we think that every house has this as their median income? No, that doesn't make sense. No, because different random samples will produce different. And then I like to include what the variable is. So different median household incomes. Household incomes. Right, that's what we're measuring. And this again is called sampling variability. Sampling variability. Ability, sorry. So no, because different random samples will produce different median household incomes. Okay, part B, it says if the sample size was increased to 1,000 households, what effect would this have on the estimated median income? So I'm going to say because the sample size increased from 371 to 1,000, we could expect our estimate to be closer to the true. And again, true is that population value to the true median income, median income for all Virginia households. Households. Try my best here. Households. So because the sample size increased from 371 to 1,000, so I need to see that part, right? So that you're understanding that it's the sample size that's doing in the increasing of the sample size. Because that happened, we could expect your estimate to be closer to the true median income for all Virginia households. If for some reason the sample size decreases, then we would be farther from the true. Okay, so see how it changes. Increased closer to the true value, decreased farther from the true value. Okay, excellent. Last objective coming.